I was in the middle of improving the code base for the plugin and realized maybe this is interesting for the rest of the world, especially if you're interested in improving the plugin. Um, Getting to at least see some of the things that's going around under the hood could be beneficial, like understanding how hard it is, how easy it is, whatever. So I'm just working on improving the code base so it will be easier to add a new feature, like making the change easy, then making the change. And I have just started to rename something that before was called a null binder to something that's called a wildcard binder, because I find that more descriptive of how I use it. If we go to the parser, we can see here that it's in the binder and it matches the underscore. So this is basically when you let's add some documentation when we're at it. So the wildcard binder is when you do things like f a function and I don't care about what the parameter actually is. So underscore in expression. It's like expression is the wrong word here, but Purescript. In code, like, yes, something. It's better than nothing. So now when we do quick documentation for this, we can see this, which is super helpful, actually. It should be, you should have more like that. So what we see here is a class representing a part of the syntax tree, and it knows about an AST node, but itself is something that's wrapping that. It's a PSI node. If we go here, a PSI element, and it's a long inheritance hierarchy, which is one of the problems with these code bases. This code base is that there's a lot of inference, and it can make it sometimes hard. I try to have as few interfaces as possible and as few delegation steps as possible, just to make it a little bit easier to understand what we're doing here. But basically, a PSI element is an object around a node in the code and syntax tree that you can delegate to do stuff and query stuff. So it's a very object-oriented way of handling a tree structure of text. And we can see here in the left, we have failing tests, but if we run them again, they will pass. And the reason for this is that most of the code in this, most of the tests in this code base is approval tests. When it touches the parser, it try to parse some code and then print a representation of the tree structure it has parsed to some files. And then it checks that they are the same as before. And since we have changed the name of a node, all of them break. So what I do then is that I go to the terminal and say remove recursively all the text files, which is the approved files in the test data directory, which is currently our name for the test data directory. You can put it wherever you like, and we have kind of settled here. It had moved around before, so it might be a different place, but you'll find that when the code breaks. And then when you run the test, it will fail because there are no files to compare with, but it creates the files, which means that the second time we run the test, they will pass. And it's good to then only do small changes when you do this thing, So if I would make a bigger change than a rename, I might want to look at the difference between the old tree before I do this. But now I know the only thing I did was rename, and I'm very trusting of tools. So I will trust this. Rename null binder to wildcard binder. I think that's good. And let's do Control K, Command K on Mac to select all the files and open this window. If it's not open, and commit. So why I was doing this was that I wanted to organize the classes that has to do with the binders, because we added some features there and it made the code a bit messy. So I'm just going through them basically one by one and saying that, okay, this file is okay. Var binder is A in the node, A in the code. So it's when you have a name in a binder, a name variable. Super helpful. I hope it is. And let's format this as well. This one can be simplified. We don't need a type. Sometimes it's good to have the type actually for performance reasons. And sometimes it's just good for, other reasons. So this is interesting. The use scope here, I don't use this as much, but I can see why this is here and it's really good. I'm going to move all the single lines to the top here as well. Makes it a little bit shorter and still allowing for the formatter to do what I want. Because if I have one here and I do format, it will add a space, which I think it's good, but I don't want it if I don't need to have it. So use scope is a method that, as we see here, override helps the Intellij tool to know where to search for text strings when it looks for references. So when you're standing on the A here and you want to find where it's used, it normally looks in the whole project, and there might be hundreds of A's in the project that it then needs to ask, okay, what's your reference? Is this adding this get use scope limits the search to only in this file, and we should really sprinkle these all over the place. I haven't done so before. I've been looking into instead improving the already existing parsing and searching so that it's quick instead of improving what to do. So we could definitely do that and hopefully make this version a bit quicker. Let's do this commit here. What did we do? We added docs and format file. So why I wanted to commit is because I want to have this in a different commit where I say factory. So we can see here some manipulation of the actual AST or the PSI structure. So whenever you change the name using keyboard shortcuts or menu refactoring, it will call this set name for the thing you're on and all the references to it. So all of them are changed at the same time. And you would guess that it's just changed textually, but it actually tries to be a little bit smarter, because if you rename something that belongs to a function, you don't want to replace the whole function body, right? You want to just change the name. So by doing this, you explain what part of the object is actually the name. So get the text string here that should be replaced. and we use our factory. So there's a PSI factory for every language, usually at least, which knows how to create new elements of a type. So here we just say create an identifier for us, and we take that name and we say, okay, replace our identifier with that name. Quite straightforward. And then for some reason you need to return yourself so that it knows if you needed to change your whole self, you've done so. And we have this guard that says if this failed for some reason, just return nothing, which maybe is weird. I don't know. So long time I wrote this. Okay, so we improved this by extracting. I'm not going to say why I did it or how I did it. I think it's good enough. Okay, so we're done with this. It looks a lot better than we were here before. We can run tests while we're looking for the next one. Oh, this is interesting. So parse binder is the node. So when you have a group of binders that have a parentheses around them, then those parentheses, and since all the nodes have all the subnodes in it, you have this box A, which is very useful actually in trying to understand stuff and do refactorings. We have a intention now that looks for parentheses that are not needed in binders, and therefore this is quite important. I'm curious if this, like, I'm sure it's used, this member here, but the question is it used, like, is there something else that could be used instead of it? Because it looks very much like get descendant binders, but okay, descendant binders just gives all the binders. This is just get children. Okay, so let's do vol binder children. And so if you don't know Kotlin, this get thing means that this is a property that is calculated every time you ask for it, which is how you want to do these things, because you don't want the node to have an old value if its contents change. So you always want to do these queries. There is ways to cache these things, and we have one mechanism which is hand-rolled in the module, because the module is like the biggest context, and therefore I find it very useful. But I'm looking for using the cache value infrastructure that exists in the editor, but I wanted to clean up the code first. So that's actually one of the goals of this refactoring, is making it easy to do that. Binder children, I think, is just this one. So if I do that, I should have extracted this one. But so since I did this a lot by hand now, let's make sure that we run the tests. Oh, why? I wonder why it didn't like me removing that. I let it be then. So now we have binder children, which is not used, and I can now do binder children. And instead of, I could go to every place where this is used, but it's not what I want. So instead, I'm just going to inline it, and then it will do all the things for me. And I can make this disappear. So it's very tiny and concise. But let's, so this is in the remove parentheses binder quick fix. So maybe we can make this a little bit nicer by us doing that. I think even this would be nice. Yeah, I like that. Okay. So move util member into super class and reform it. I don't remember if I ran test. Let's run a test. Can always run test one more time. Okay, so this one, now we're here. So in named binder, I think, so I'll write this out and then we'll check in the parser to make sure. But I think a named binder is the node A in the code. Can I do it like this? Probably. So when you have, I don't know if you need to have parentheses actually around this, maybe. So when you have value, but you also want to be able to reference it, this is more useful actually when you have things like box a, let's call it box. When you want to be able to reference it later, but you also want to be able to unpack it. So if we go here, I follow a link here, and then I go to the type. So then I find it here. So it's actually the whole thing. So it's box A. There it is. So let's see that was formats okay. Yes. So it's the node box. Da, 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 da. So we can see that if we follow this, at some point, it would be nice to have a. Oh, it's the left-hand side that is the name. Okay, so it should be actually. You can definitely see what features of Purescript I'm not using. Most of the time, I'm not a big user of this. Let's actually run the IDE so that we can see that this code works. So and at Right, and we can see that we have a bug here. We are not looking into these to find the names, it seems. So maybe that needs to be fixed. Now it's complete. And now it works. That's weird. And if I remove it? So there's definitely a bug here that needs to be fixed at some point. But it seems like as long as it had the whole part from the beginning when it started parsing, it worked. It's just something with the parsing doesn't work completely. Maybe it just took time. Who knows? Okay, so at least we have described this. We have some help. There was not much cleanup. Add doc comment. Feels like double useful to both add a comment and explain to you at the same time. So constructor binder is, we have seen it many times now. If we have, so it would be the node box in the code. So let's do it m dot, as to clarify that it's with module as well, with qualifier, I mean. I wonder if we have rename support for these. Anyway, let's go to elements file and here just to check. So it's in binder atom and binder 2. Let's see here. So here it represents the qualifier name, if it's just that name. And if we go to the second place, it's the name and then multiple binder atoms after itself. So it doesn't include the parameters to the, it's called type constructor. So if this was a function call, we would have like a recursive collection of the constructor and then the first argument and then that result and then second argument with like parentheses around, if you think about it like a tree structure. But here we don't. That might change because it was really helpful for the expression version of constructor binder. This constructor. Okay, then we have binder. Let's commit add.comment. Did the test fail and I didn't notice? Oh, no. We were in a editor and it failed. Let's run the tests. We have array binder, which is, let's copy the constructor binder and we'll just do edits to it. So it's So you can destructure arrays like this. It will complain because the function is not complete, but you can then add other ways to match. So pun binder, this one we can clean up some. Do that. Let's put it up there. Yeah, let's put it before, since it's used in name. So pun binder, you can have, this is called a pun, which is when, like, if you have a record, you can have, I can see here that I should have changed. The code before was not working. Anyway, when you have a record with a name and a value, you don't need to unpack the whole label. Like, you could write this, but if the variable you want and the key has the same name, you can just use that name, and that's the pun. I did that not. It's also should I care that the code there doesn't work? No. Let's move over to record binder. Is it's actually should be because this is that node. Oh no, this is the label. So then it's if we go to here, go to the parser, you can see that it's label plus an equals or a comma, and then we have the expression. So that's that. Copy this and go to record binder, and now it's let's add a B as well. Make it more interesting and complete. I'm not sure I'm gonna add documents to these because they are quite simple to understand, I think. But that is when you have a literal. So if you have a number that you're matching against. Awesome. None of them have weird methods or anything that need to clean up? No. I'm quite happy with the binder, and I think that's enough for this recording. Um, so thank you for joining me and seeing a bit of the code behind the scenes, and have a nice day.